In this lecture, I'm going to expand on variables and talk about the powerful idea of collections. And we'll learn about lists, which is one of the most important types of collections. Collection in general are a group of things that can be handled as their individual elements and can also be treated as a whole. For example, you can look at a bowl of fruit and see that it is a collection of things. It contains a number of individual elements: oranges, apples, pears, grapes, bananas, etc. But it can also be treated as a single thing, a bowl of fruit. If you wanted to move the fruit from, say, the kitchen to the living room, you wouldn't have to empty the bowl and move the fruit individually. You could just take the whole bowl of fruit and move it all. Feel the power? We can think of the bowl as a collection that includes items of fruit. Before I go into types of collections, let's talk in generalities about why you would need them. Just as I intimated in the bowl of fruit example, collections are handy because they can be acted on as a whole, gathering together a number of identical actions for each of the bowl's contents. Say we are out in our imaginary orchard and we were looking at all the ripe fruit on our trees. If we wanted to pick a selection of fruit to bring inside, we wouldn't pick an apple and walk it inside, then go back out, pick an orange, bring it inside, and then go back again, pick a lemon, and come back inside, right? Wouldn't it be much simpler to bring out a basket, pick the fruit, put them in the basket, and then bring the basket with all the fruit inside? In the same way, we can use collections to store things until such time as we want to use them. We can also remove them. We can do many other things like even counting them. There are three types of collections: lists, sets, and maps. Let's talk about lists. According to the definition, list is an ordered collection of elements that are distinguished by their indices. Let me break it down for you. A collection of elements means a group of things. An ordered collection means each member of the list has a specific place within the list, kind of like an address. The order of the elements is distinguished by its index. We can tell where each element lives because it has an address we can point to and use a particular item in the list using its address. Let's take our fruit and arrange them in an orderly fashion. If we superimpose our platter of fruit with the list variable, we see that we have one variable that represents the list as a whole, and we can reference each element in the list by its index or its numeric address. You can see that the address, index as we call it, for the platter starts at 0. This is just one of those rules you have to remember. In Apex, like most other programming languages, we start counting our elements in our list from 0. The first element of the list index is 0, the second element's index is 1, the third element's index is 2, and so on. We can use our developer console to write code. Let me open the Execute Anonymous window. In Apex code, we can define a list using the following syntax: list, data type, list name equals new list, data type. I know, it might not be so easy to remember, but you'll get used to it. If we were to initialize this list with couple of values, it would look something like this: list, data type, list name equals new list, data type, along with these values. Let's define a list called platter with 3 existing fruit. Since we would be putting in names of fruit, the data type is string, and we are initializing the list with 3 values: apple, orange, and a banana. List string platter equals new list string apple, orange, banana. Since we have a list now, there are a couple of methods that let us work with these lists. For example, to add an element to the list, I could use the add method. This would add a peer to the list. If I do this again, then another peer would be added to my platter. This means if we run this code, we would have 5 elements in total. You remember, we initialized the platter with 3 elements and then we added 2 peers. Let's use a system.debug statement to capture the platter size after the code runs. The syntax is pretty easy to remember, system.debug. I could put in whatever text I want in the quotes. The platter size is plus platter.size. Like the add method we used earlier, we have a method called size that would count the elements in the list. Let's run this code and take a look at the log. I'm not interested in all the details of the log. I'm curious only about the debug statement I've written. You can now see that the platter size is 5. We just learned another list method called size. So if we wanted, how do we pull out the first element in the platter? We can use a method called get. Let's write another debug statement to say the first element is platter.getZero. Here, 0 is the index. System.debug is super handy. It'll just log the value for you to take a look at. You would want to use this in pretty much every piece of code you write. Let's run this code and take a look at the log once again. We can see both the debug statements. The number of elements are 5. The first element is apple. Let's play with few more methods. To remove an element from the list, I can do platter.remove and the index. This would remove the first element. Let me write another debug statement to verify the platter size after removing the first element. This should read 4. We can even clone our platter list using a clone method. Here, I'm creating a clone of platter called bowl. List string bowl equals platter.clone. Let me also display the contents of the bowl using a debug statement. System.debug contents of bowl plus bowl. And if I wanted to replace an element in the list, I could use a set method like this one. Let's try to replace the third element in the bowl with grapes. Bowl.set. So 3 is the index and grapes is the element. So we are replacing the third element in the bowl with grapes. Let me also write another debug statement to validate that. System.debug contents of bowl plus bowl. We can also sort the elements in ascending order using a sort method. I want to make a small note here. The elements in the list can only be primitive for the sort to work. Another debug statement to show the sorted elements in the bowl. I want to show you 2 more methods before I run this code. This would remove all the elements in the platter list. I can also validate if the platter is empty by using the isEmpty method. This would return true if the platter is actually empty. Let's run this code. We have debug statements all over, which makes it easy to understand what's going on. Let's take a look at the log. We started with 3 elements, but added 2 pairs, and now we have 5 elements. The first one in the list was apple. Then we removed one, so we had 4 elements. We cloned our platter and called it bowl. We can see its contents. Then we tried to replace the 4th element in the bowl with grapes. We then sorted the elements of the bowl with the sort method and emptied the platter using the clear method. And we are checking to see if the list is actually empty using the isEmpty method, and it returned true. There are a whole bunch of list methods you can play with. You can find them in the cheat sheet. Summing up, by now, I hope you agree with me that collections can be useful. Collections in general are a group of things that can be handled as their individual elements and can also be treated as a whole. There are 3 types of collections: lists, sets, and maps. They are super helpful as temporary storage. Lists are ordered collection of primitives and distinguished by their indices. Remember that the numbering starts with 0. And lists can contain duplicate values. We have a whole bunch of methods to work with. We can add, remove, get an element from the list, calculate the size, clone, sort, clear off the list, and check to see if the list is empty. It's fun to play with lists. There are a lot more things we can do with lists that I haven't covered here. For more information, check out the cheat sheet that shows you things you can do with lists. In the next lecture, I'll talk about another interesting type of collection called sets.